When it comes to pharmaceutical compounds, particle size is extremely important. Most physical changes that take place upon an object begin at the surface, such as an ice cube melting or food in the microwave heating. The aspect of interest to us here is that when a solid dissolves, it does so at the surface. If you compare two objects of identical shape, the smaller one will have greater surface area to volume ratio. In other words, the same amount of a solid will dissolve faster if it is in smaller pieces. If a pharmaceutical compound crystallizes into extremely fine particles, then it will dissolve faster and may be absorbed faster. However, this isn't always a positive aspect, and we will discuss that when we begin talking about pharmacokinetics. More important in the early stages is identifying whether the particles are uniform in size. Large crystals, accompanied by fine powder, will require some form of processing to get them to the same size to ensure that the release in the body is controlled. Small crystals can be grown larger by placing them in saturated suspensions and slowly cycling the temperature, a process called Ostwald ripening. The smaller crystals dissolve faster as the temperature increases, leaving the larger ones behind, and these will template the new crystal formation when the temperature drops. Alternatively, larger crystals can be milled to grind them into smaller pieces, which is an extremely common practice. If the material already demonstrates a uniform particle size, then the existing crystallization process that generated it will only need minimal optimization to be adapted at the manufacturing scale.